Welcome students to part 2 of the golden rules for making patterns using nested loop. Please refer to the previous video. The link of the previous video is in the description. Now this pattern we can see has most number of numbers printed on the first row, and gradually it is tapering, and then at the last it is becoming a single number. Now why do we call it a pattern? Because we can see that something similar is happening in every row. Similarity is in every row the numbers are starting from 1, but it is finishing with a different number. So now we need to represent this in a program. Now to understand this, we need to learn the nested loops in a very good depth. But before doing that, let us exercise a set rule, a shortcut, a golden trick which will give me the output, what I desire. Now in the subsequent videos I will tell you about how to decode this golden rule, this trick. And when you will reach that, you will achieve entire control over the nested loops. Nested loops are the foundation of the algorithms which are run on arrays. You need to do any type of sorting, you need to do any type of two-dimensional array related operation. Mostly a nested loop is used. So it is very important part of programming. So now in a little different way, let us try to understand how to get this final pattern on the output screen. Now it is 1 to 5 I can observe. So I have already written the representation of the inner column here in a tabular structure, as I have told you earlier in the previous video also, that we need to put a 2-column table, where in the inner column we are going to write what we can see in the rows. Here we can see in the first row it is going from 1 till 5. So I have written it as 1 till 5. In a similar fashion, 1 to 4, so 1 to 4, 1 to 3, here also it is 1 to 3, then 1 to 2, and here 1. So it's 1 to 1. Why I have written it as 1 to 1? Because I needed to give a generalized structure to all the rows. Now the next step in the rule says that I need to fix the outer loop. Now to fix the outer loop, it is very simple and easy. What you can do is, whatever is fixed, you leave it. Whatever is changing in the second column, you pick it up. So what we can see? We can see here the final ending number with which each row is ending is changing every time. So for the first row it is 5, isn't it? So now I'll write the next, then the next, then the next, and then the next. Now that's all. My table is ready. Now what next I need to observe from here is, I need to observe how the loop variable I or the control variable I is behaving. So to check it, the outermost loop always needs to be seen in top to down fashion. So what we can see here is, it is starting from 5 going till 1. Now what I will write, I'll write I equals to, starting from 5 going till 1. And how is it going? To go from 5 to 1, we need to decrease the value of I. And how the value is to be decreased? You can see gradually in every step it is decreasing by 1. So I will consider -1 to be the movement of it. Now, what next we need to observe? The next thing that we need to observe is how the inner loop J is responding to the outer loop. Now, in that case, what we need to do is we need to check it horizontally. Now, here you can see that every time in every row it is starting from 1. But the number with which it is ending is changing. And those numbers only we have placed in the column of I. That means the value of J is going to start from 1 and go till 5 when the value of I is 5. I'm repeating. When the value of J goes from 1 to 5, we can see that the value of I is also 5. In a similar fashion, the value of J, when it is from 1 to 4, we can see that the value of I is also 4. So, in this case, if we are taking all the rows horizontally one by one, and then we want to give a general picture to the whole thing, what we need to do? Here, we can write that J is starting from 1. Yes, it is starting from 1 every time. But till when it is changing or going? Till some value which is changing every time. But this value has a relation with the value of I. And what is the relation? It is equal to that. So I can, in place of writing a number here, because I cannot write it as a fixed number, because if I write 5, for all the rows it is not running for 5 times. It is running for I number of times, because when the value of I is 5, it is running for 5 times. When the value of I is 4, it is running for 4 times. And in what way it is changing? In what way it is printing the numbers? Like if we see 1, 2, 3, 4, 5, we can notice here that gradually the numbers are increasing by 1. So I'll write plus 1. That's all. Now my work is done here. Now what I need to do is, what I have obtained here, I will have to code for this. And this code is going to give me this pattern on the screen. So for that, I'm going to take you to the program editor screen. I'm using BlueJ. It is a free IDE. And I have already written a little part of the program. Now what I want you to see here is just the required details, required code which will be representing this thing is going to take what shape. I'll be requiring two variables, I and j. I is going to rule the outer loop and j is going to run the inner loop. Now the outer loop goes like, I'll just copy this thing here, but while copying I'll not keep the same representation. I'll just make a little change as per the syntax of the loop. Now what I have written, see, I have written the value of I is going to initialize by 5. So I have written I equals to 5, and then I less than equals to, sorry, I is greater than equals to 1. Why greater than equals to? Because 5, 4, 3, 2, 1, all these values are greater than or equal to 1. Now, what shall I write? I should be decremented by 1 every time. So this goes this way. Now, it's the turn of writing the inner loop. So inner loop comes with the structure of for j equals to, what we can see there, initialize to 1 and j goes till I, and then j is incrementing by 1 every time. Now the interesting thing is when to write greater than equals to and when to write less than equals to. Now what I said, I needed from 5 to 1. So all the values from 5 to 1 in context to the final value are greater than or equal to 1. Whereas in this case, I want 1 to I and it is increasing. The initial value of j is 1. So 1 up to I, all those values are going to be either less or equal to I. So here j is less than equals to I should be written to limit the loop. Now my work is almost done. I'm just going to type this statement, which is going to give me the value of j printed on the screen without breaking the line. Now next one I've written after breaking it. Now my program is ready. Let's compile it and see whether it gives me the same output what I expected. It is showing no syntax error. That means there is no problem in the compilation. Now this is the block. I will run it and see. This is something what we needed. One small thing I'll introduce in this. I'm going to bring some more change in the code. What I will do is, while I was printing j, I found that only numbers are getting printed. Now I'm concatenating a blank space along with it. I'm compiling it again. There is no syntax error. Now running it, what we can notice, there are gaps in between the numbers. So that's all. Take few more patterns of your own choice and then try this golden rule, and please let me know in the comments below, are you liking it or not. Thank you.